Hello, welcome to section 2.3. What we're going to do is talk about linear inequalities. So throughout this video, what we're going to do is we'll be given a situation for a problem, and we're going to work through and figure out how many tickets a person must sell to make at least or at most a certain amount of money. And we're going to be using a graph to determine that, and then what we're going to do is use an equation to determine kind of the same thing. And then towards the end of the video, we'll be drawing on the graphs to figure out where a person is at a certain amount of time. So get this started. In this first example, it says Elena works at a ticket booth of a local playhouse. So on the opening night of a play, tickets are $10 each. Playhouse has already sold $500 worth of tickets, and then the function here models it. So let's notice, and I'm going to touch on a couple of things that were in section 2.2. Let's talk about, first of all, my x value is going to represent the number of tickets she's selling. F of x is going to represent the amount of money, so that's going to represent our output value. 10 is my rate of change. Notice it's $10 per ticket. So what that means is that your input value would be the number of tickets sold, and your output value would be the amount of dollars that the person collected. And then let's talk about the fact that when they sold 0 tickets, they already had this amount, which is our y-intercept of 500. So notice where the function over here crosses the y-axis at 500. That's because they already have that money. With 0 tickets, when x is 0, y is 500. Or you could say when x is 0, f of x equals 500. Same thing, both talking about what y-intercept is. So what we're going to do is figure out how many tickets, in this first example, she must sell in order to make less than $800. So what I'm going to do is go all the way over to my graph. Since I'm giving you a quantity of 800, we're going to look where 800 is and go to where this intersection is. So I know that if she wanted to make $800, she would have to sell 30 tickets. So let's think about that in words again. If she wanted to make $800, she would have to sell 30 tickets. So let's go back over to this now. It says how many tickets must she sell to make less than the $800. So I know that if she sells 30 tickets, because that's where the intersection was, if she sells the 30 tickets, she'll reach 800. But I want to know how much she's going to sell to make less than that. So if she sells 20 tickets or 10 tickets, that's going to be everything that's less than $800. So what I'm going to do is go to where 30 is, and I'm going to put an open dot there. And I'm going to explain why in a second. And what I'm going to do is draw an arrow that's going to be pointing to the left, which represents that if she sells 5 tickets, 10 tickets, 20 tickets, any amount of those, if I go back to this graph, any amount of those tickets will give me a value for y that is less than $800. So let's kind of take a sec to talk about why I have an open dot here, and that's because I want to know how many tickets she's selling to make less than this, not less than or equal to, because I don't want her to reach $800. I want to know how many tickets to make less than $800. So I'm going to leave an open dot there, which means I don't want to sell the 30 tickets. I don't want to get the $800. I want everything that is below that, so everything less than 30. So if I wanted to write an expression for that, I would say x is less than 30 tickets. How many tickets must she sell in order to make at least $1,200? So I'm going to go back to the chart again. I'm going to delete these things off of here. And now let's draw a line over going from where 1,200 is. So we want to know for her to make at least $1,200. That looks like 70 tickets. So let's go back to this. If she sells 70 tickets, she will reach $1,200. So let's think about this. Her goal is to make at least $1,200. So can she reach $1,200? Yes. Can she be $1,300? Yes. $1,400. So what I'm going to do is close this dot. The reason for that is because I want to know if she makes at least that amount means that she can be greater than or equal to $1,200. So if she wants to make at least $1,200, she needs to sell at least 70 tickets. So I would say greater than or equal to. Notice it's a closed dot, and since it's greater than or equal to, we're going to draw an arrow pointing to the right. And what that means is if she sells 80 tickets or 90 tickets or 100 tickets, she will earn at least $1,200. If she sells 70 tickets, she will earn at least $1,200. So that's why we're closing the dot, and in the last example, we left it open. So this one, kind of interesting. It says how many tickets must she sell in order to make exactly $1,400. So that's where I'm going to go all the way up to 1,400 on my graph here. I'm going to draw an arrow over, and then I'm going to go straight down. So for her to earn at exactly $1,400, not $1,390, not $1,420, she wants to earn exactly $1,400. So what that means is she would need to sell 90 tickets to reach that. And if she sells 89 tickets, or if she sells 91 tickets, that would be too much or too little. So exactly 1,400 means she would need to sell exactly 90 tickets. So what we're going to do is just put a dot on our graph, and we're going to shade it in. We're coloring it in because that represents a solution to the problem. Just like in the last example, we colored it in because even if she sold the 70, she still made that 1,200. So if they're meeting that goal and it's part of your solution, you want to color that dot in. And that's what we did here. Notice, I'm not going to draw an arrow going to the left or right because I want her to sell exactly $1,400 worth of tickets. So then, in those examples, we used a graph. The ones that we're going to do next, we're going to use an equation for. So Leon plays on the varsity basketball team. So far this season, he had scored a total of 52 points. He scores an average of 13 points per game. So here's my function again. F of x equals 13x plus 52, representing the total number of points he's going to score this season. Write and solve an inequality to answer each question. So how many more games must he play in order to score at least 117 points? So let's think about this. Our input value is going to be the x here, and that's going to represent the number of games that he's playing. We know that his rate of change is 13, and that's points per game. So x is the number of games. F of x is going to represent my output here, which is going to be the number of points that he scores. So however many games he plays, if you think about it, the more games he plays, the more points he'll earn. So right now, he's already earned the 52, so I know that 13x plus 52, and I want him to earn at least 117 points. So can he earn 117? Yes. Can he earn 120? Yes. Can he earn 110 for at least? No. So everything that is greater than or equal to 117 is part of my solution. So now what we're going to do is solve this equation. So I'm going to subtract 52 on both sides. I'm going to cross that off, and I'm left with 13x is greater than or equal to 117 minus 52, which is going to be 65. And x is greater than or equal to 5. So it says how many more games must he play? So if I'm going to write out a sentence for this, I would say Leon must play at least 5 more games, or 5 games. So if he plays 5 games, he will earn exactly 117 points. If he plays 6 games, he would earn 13 more points. That's 130 points. So all of those are going to represent the number of solutions. So my solution here really is this part, though, where x is greater than or equal to 5. In the next problem, how many more games must he play in order to earn fewer than 182? So we don't want him to earn 182 points. We don't want him to earn 200 points. We want fewer than 182. So 13x plus 52. So since it's fewer than, it's going to have to be less than. And again, it's not fewer than or equal to. It's not less than or equal to. It's just less than. It's fewer than 182 points. So we're going to put 182 on the right side and leave our inequality like this. So solve this the same exact way. I'm going to subtract 52 on both sides of this. So taking 182 minus 52, I'm going to end up with 13x is less than 130. So then what I'm going to do is divide both sides then here by 13. and end up with x is less than 10. So how many more games must he play to score fewer than this? If he plays, so that's what I'm going to write below, Leon must play fewer than or less than 10 games. So think about this. If he plays 10 games, that means I would do 13 times 10, which is 130, and if you added 52, you would have 182 points. So if he plays 10 games, he will earn 182 points. But I don't want him to earn 182 points. I want him to earn fewer than 182 points. So he cannot play that 10th game. If he plays that 10th game, he's going to earn the 182 points, and that's not what the problem is asking for. So he must play less than 10 games. So 9 games would be okay, or 8 games would be okay. And then the last one of those, how many more games must he play in order to score more than 200 points? So the same thing, I'm going to take 13x plus 52, and I want more than 200 points. So if he earns 200, that's not enough. It has to be more than 200 points. So notice it's going to be greater than. So 13x, when I subtract my 52 on both sides, I end up with 13x is greater than 148. And then what we're going to do is divide both sides by 13. And I'm going to get a really ugly number here. So x is greater than 11.38 games. So here's the problem. He can't play 11.38 games. He's either going to play 11 games or 12 games or 13 games. So if he plays 11 games, notice, if I round down, you might want to round down because of the 0.38, but think about this. If he plays 11 games, that means I would be doing 13 times 11 plus 52. So I'm going to go to my calculator for this. 13 times 11 means that he would be earning an additional 143 points plus 52, and that means he would earn 195. So I got to ask the question, how many points was he trying to get to? And hopefully you're thinking 200. He wants to score more than 200 points though. So if he plays 11 games, he's not going to quite reach that. So Leon has to play at least 12 games. So what I have to do is round up then. I know that if I round down, and I round down to 11 games, it's not going to be enough. So he needs to play that 12th game, and that will give him more than 200 points. So I end up rounding up. You could also just leave your inequality as x is greater than 11.38. If he plays like 11 and a half games, for whatever reason, if he's allowed to play a half, that would work then. So anything greater than 11.38 games is going to allow him to. So I'm rounding up because I'm talking about whole games here. And then the last ones, we're going to go to the graph on these. So it says draw an oval on the graph to represent the solution to each one of these, the questions, and then write the corresponding inequality. So we kind of did problems like this a little bit ago, but now we're going to be drawing an oval on this graph. So a bathtub is filled with 55 gallons of water and it's being drained. So notice my y-intercept here before it's drained, we're already at 55 gallons. The water is draining at a rate of 5 gallons per minute. Here's your function. Notice the 5 is negative because we're draining the water. Here's your y-intercept. It's the amount that we're starting with. And that represents the volume of the tub as it's draining. How many minutes have passed if the tub still has more than 20 gallons remaining in it? So I want to find where 20 gallons is on my graph. Notice I'm going to the y value here, and here's where 20 is. So let's look at what that corresponding time is. And that looks like it'd be 7 minutes. So it says I want to know how many minutes have passed for the tub to have more than 20 gallons. So what happens after 7 minutes? Well, the tub is going to have less than 20 gallons. So I want to know, when is the tub going to have more than 20 gallons? So I know that once it reaches 7, it has 20 gallons. So when is it going to have more than 20 gallons? Well, that's everything less than 7 minutes. So x in this case is less than 7. So I'm going to ask the question, why is it not x is less than or equal to 7. Why is this wrong and this one's right? And what I want you to think about is once we hit that 7 minutes, how many gallons are left? And it's 20. But I want to know how many minutes have passed when the tub has more than the 20 gallons. So I don't want to wait 7 minutes. I want x to be less than 7 minutes so that the tub has 20 gallons of water or more, or I'm sorry, it has more than the 20 gallons of water. Last one, a submarine is diving from the surface of the water again at a rate of 20 feet per minute. Here's my function. It's going underwater, so that's why we have the negative rate. And again, f of x is going to represent the depth of the submarine as it's diving. How many minutes have passed if the submarine is at least 160 feet below the surface? So I want to know where how many minutes have passed when it's 160, when it's 170, when it's 180. I want to know at least 160 feet. So I'm going to go on the y-axis, and we're going to find where negative 160 is. Because we're feet below the surface, I don't want to be above here. I want to be below. So looks like 200's down here, which means negative 100 would be about halfway. And then it looks like we're counting by 20s. So 160 is going to be down here. So what I'm going to do is draw a line going straight over. And notice where that intersection is. And then I'm going to draw a line going straight up. And that's 1, 2, 3, 4, 5, 6, 7, 8. So 8 is going to be my x value. That's going to represent my number of minutes that the submarine is underwater. So I know that after 8 minutes, the submarine is 160 feet. After 9 minutes, the submarine would be 180 feet, and that's okay. So I'm looking for how many minutes would have to pass for it to be at least 160. So I'm going to draw in right there. And if we look at our x values, that's where 8 starts. So my x values are going to be greater than or equal to 8. So notice now I'm putting the greater than or equal to because it's okay if he reaches 160. In the last example, and I go back to that, we were looking for more than. Notice now we're saying at least. When we put at least, that means that word equal to has to be in there somewhere. So greater than or equal to, in this case, 8 minutes, means that this person would be at least 160 feet below the surface. So again, go back and recap what we did here towards the beginning of this. We used a graph to determine how to solve an inequality if I gave you an output value. And then we went back and we used equations, or I'm sorry, we used inequalities to figure out algebraically how to solve for an input value. And then at the very end, again, we drew the oval on the graph, so we made a connection between using the inequality and using a graph to display our answer.